Okay, so now we're going to pick up where we left off, talking about the observation that we just made, that if we reflected and then reflected again, we get something that was like a slide, a translation. This question is asking us, what if the lines of reflection are not parallel? So here we have a line of reflection V, we have a line of reflection W, clearly not parallel to each other. So first we're going to reflect EFG over line V, and then we're going to reflect that image over line W to get triangle E double prime, F double prime, G double prime, and see what happens when the lines are not parallel. So first we're going to go 3 away from the line of reflection, but still keep it at that 90-degree angle when we go straight across. Same thing with G. 4, 5, 6, 7, 8, 9, 10, 11. That's going to give us G prime. We've got F prime. And then if we go up 3, left 2, that would be E prime. And if we connect these, you can see that it did the same thing as it did before. It flipped G, which was furthest away. Now G prime is furthest away. F, which was closest. F prime is now closest. And the two shapes stayed congruent. All they did was change their orientation. One was sort of pointing to the right, and one is now sort of pointing to the left. Now let's reflect over this line. And what I'm going to do is actually turn my page so that my line of reflection is vertical. I find that to be easier. You don't have to if it's not a problem for you. But I'm going to go at a 90-degree angle, which is 1.5 squares diagonal, and then I'm going to go 1.5 squares diagonal to the other side. There's that 90-degree angle that you can see across the line of reflection. I'm going to do the same thing here. I'm going to go 1, 2, 3, 4 diagonals. 1, 2, 3, 4 diagonals. A little bit harder to see. That's going to be E double prime. This one's going to be G double prime, and then F is going to be 1, 2, 3, 4, 5.5, half, 1, 2, 3, 4, 5, working on the diagonal again. And we're going to have this shape, which you'll notice lined up kind of nicely. Like this one had a horizontal base. Now this one has a vertical side to it. And then this is going to be F double prime. All right, so is the first image a translation? Is it just simply a slide or a shift? And we would say, no, it's not, because it has changed orientation. So describe the result. It's actually been rotated. The triangle has been rotated. Okay, now how do I know this? I know this because if I were to connect, you can see this point right here where line V and line W intersect. If I were to connect using a ruler, okay, I'm going to go F back to point P, which is where those two lines intersect. And then I'm also going to go from point P where those two lines intersect over to F prime. Now, if we just for a second pretend that F is the origin, you can see that there's actually a 90-degree rotation. Another way of looking at this, if I hold the paper this way, can you see the 90-degree angle? We've got one shape that's sort of up here. If we were to rotate the paper 90 degrees, see the orientation of this shape? Looks kind of like a flag sticking off the top. If I were to rotate it 90 degrees, you can see that it now has that same flag sticking off the top shape to it that the original one had. So it has been a 90-degree rotation. And if you look at it, you went from here over to here. So we could say it's 90 degrees, and it's going in the shape of, going in the direction that clock hands go. So it would be 90 degrees clockwise rotation. You could also say, no, it didn't go that way. Maybe it went the other way. Maybe it went around the back side and got there. Well, if that's the case and it did this, then it would be a 270-degree counterclockwise, meaning not in the direction that the clock hands go, rotation. So a 90-degree clockwise is the same, or will get you to the same location as a 270 degrees counterclockwise rotation. All right. Amanda noticed that when the reflecting lines are not parallel, the image was a rotation of the original figure. For example, the diagram at the right shows the result when an ice cream cone is rotated about a point. We call that point the center of rotation. So if you thought about having that ice cream cone as like a little sticker and you put it on the end of the minute hand of a clock and you let the clock sort of tick by, you would notice that the ice cream cone would rotate on the end of the minute hand. In part A, the center of rotation was point B, the point of intersection of the two lines. We could also pretend that it was the origin. Use a piece of tracing paper to test that triangle E prime, F prime, G prime can be obtained by rotating triangle EFG about point P. To do this, first trace triangle EFG and the plus sign, and then you're going to rotate your tracing paper so that EFG is now on top of E prime, F prime, G prime. And if you want to do this at home and you don't have tracing paper, you can use a piece of wax paper will work. You can cut out a small piece of wax paper from the kitchen. So just if you want to try that out. All right, so the rotation of triangle EFG in part A is an example of a 90-degree clockwise rotation, clockwise referring to the way the hands of a clock move. The rotation in the opposite direction is counterclockwise. Performing a rotation, again, noticing the starting and ending orientation of the center. So when we did that, we were rotating it, thinking about where the middle of the clock would be. Is it possible to rotate triangle EFG counterclockwise to obtain E prime, F prime, G prime? We said yes, that a 90-degree clockwise was going to be the same as a 270-degree, and sometimes people will write counterclockwise rotation and just do the double C's. Is the figure, okay, new one, let me slide that up. Is the figure at the right a polygon? Polygon meaning many-sided figure. The sides have to be connected. They have to be a closed shape. It has to be straight sides. So is it a polygon? Yes. We would call it a concave hexagon. And this was from 7th grade. Concave because we have this corner right here, this vertex that's caved in. Hexagon because it has 6 sides. Give the original coordinates and the coordinates of the image of a 90-degree counterclockwise rotation. So let's just start with the original. So the points that are on here, P is 0, 6, Q is the origin, 0, 0, R is 4, 0, S, 4, 2, T, 2, 2, and U, 2, 6. Now, if we want to rotate it 90 degrees counterclockwise, the first thing we want to do is say, right now it's in quadrant 1. If it goes counterclockwise, it's going to end up over here in quadrant 2. Here's the easiest way to do this, and it's going to involve moving your paper. Right now, point R, it takes me 1, 2, 3, 4 squares or 4 units to get from the origin to R. I want this thing in quadrant 1 to move over here to quadrant 2. So to get to R, I have to go 4 to the right. I'm going to physically turn my paper so that where the quadrant 1 was sitting, now quadrant 2 is in that spot. And I'm going to go 1, 2, 3, 4 to the right, and that's going to give me R prime. I'm going to rotate my paper back. And I'm going to say, okay, to get from the origin to S, I'm going to have to go 1, 2, 3, 4 to the right, up 2. I'm going to rotate my paper and go 4 to the right, up 2 to get S prime. I'm going to look back at the original. To get to T, I have to go right 2, up 2. Physically rotate my paper. I'm going to go right 2, up 2, and there's T prime. Sounds like I'm talking about like a rap star or something. To get to U, right 2, 1, 2, 3, 4, 5, 6, up. Rotate my paper. Right 2, 1, 2, 3, 4, 5, 6, up. Hopefully at this point you can start to see that boot shape or L shape forming. And to get to P is just straight up 6. So when I rotate my paper and I go straight up 6, I am here. And you'll notice that Q is not going to move because Q is actually on the origin. So my image is going to be the L shape. And because I rotated where I wanted the shape to end up in quadrant 2, I rotated it so that it was now looking like it was quadrant 1. My shape ended up in the space I was looking for. Translation, like words translation, if you want something to end up in quadrant 2 due to a counterclockwise rotation, you actually rotate your paper clockwise. So in order to get a 90-degree counterclockwise rotation, you rotate your paper 90 degrees clockwise. The image points become, and I'm just taking them off the picture here, what I just drew in marker, negative 6, 0, 0, 0, 0, 4, negative 2, 4, negative 2, 2, and negative 6, 2. So if you would like to avoid ever having to do that process yourself, you can start looking at connections between the original points and the image points. So how did I get from this one to this one? If I look at the coordinates, you'll notice that like 2, 6 is now 6, 2. So the first thing is that the X and the Y coordinates switch. So the X and Y coordinates switch. And the new X coordinate, so it was a 6 in the Y coordinate. Now it's a -6 in the X spot. So when it switches, the new X becomes the opposite. And in order to write that, you'll see down here, we've got our rotations. And we would say this one right here, a rotation of 90 degrees. We would say that a rotation, capital R, of 90 degrees for a coordinate XY becomes -YX. They swap spots and the new one in the X position becomes its opposite. So that's this one, the top one here in the table for things to memorize. All of these are clockwise. You'll see it says this is for counterclockwise rotations. This table, very specifically, all 3 of these rules are specifically for counterclockwise. So if the directions on an assignment asked you to rotate something clockwise, in your head, you would have to say, oh, well, if it's a 270 degree clockwise, that's equal to a 90 degree counterclockwise. And then you would look up the table and say, what do I do for a 90 degree counterclockwise? You are not going to look up the clockwise direction. So that's really important to remember. You're probably going to want to go back and watch this part or listen to this part again in the future when you're working on the homework. Given the points H92, I41, and J63, write the coordinates of the image after the following. So we've also got up here the rules for a rotation of 180 degrees. You'll notice XY stays XY, but they both become their opposites. So for a rotation of 180, the point was 9,2. It's going to stay 9,2, but they're both going to become their opposites. 4,1 is going to stay 4,1, but they're both going to become their opposites. 6,3 is going to stay 6,3, but they're both going to become their opposites. Now for a 270, a rotation of 270 counterclockwise, they switch spots, right? XY becomes YX, but the new Y, the second one, only becomes the opposite. So instead of 9,2, they're going to switch spots 2, and the new Y becomes the opposite. For I, they're going to switch spots 1, and the 4 becomes the opposite. I'm looking back up here at the original. J was 6,3. So it's going to switch spots 3, and the new Y, 6, is going to become its opposite. This is the part of the video that you're probably going to want to rewind and watch again, or maybe watch again tomorrow. But as I said in 311, making a set of flashcards for yourself, really imperative for memorizing these. So I'm going to stop the video here and make a new video for the page 3 so that if you do need to go back and rewatch it, you're only rewatching this part of the video.